Hey there again, AP Environmental Science. Here we go with sustainability, economics, and equity. Economic health depends on the availability of natural capital and basic human welfare. Capital and or in totality of our economic assets, that's typically divided into three categories: natural, human, and manufactured. All right, natural capital refers to a resource on the planet, like air, water, minerals, that type of thing. Human capital refers to human knowledge and our abilities. And manufactured capital refers to all goods and services that are human produced. While economists usually base their assets or their assessments of national wealth on productivity and consumption, environmental scientists point out that all economic systems require a foundation of natural capital. I mean, basically, without natural capital, humans would not be able to produce very much at all, and we would probably not survive. So, to all those economists out there and businessmen, and as an environmental scientist, to make sure that we don't ruin all these natural resources that you make a ton of money off of, you're welcome. Environmental and ecological economics. Some advocates of a purely free market system believe that as long as the market forces the arrow to the left, human work and creativity will find some solution to all these problems and natural resource degradation and depletion. But as we've seen, in the past, externalities are not assessed appropriately, and the cost of environmental destruction is not charged to the individual who's responsible for all this destruction. And so a market failure occurs when the economic system does not account for all the cost. Among those economic thinkers, we who have sought some sort of way to respond to these market failures, many of them have become part of a discussion in which the fields of environmental economics and ecological economics are. We call that environmental economics. And that's basically a subfield of economics that examines the costs and benefits of various policies, regulations that seek to benefit various things like water pollution and environmental destruction. This differs from ecological economics, which is the study of economics as a component of ecological systems rather than as a distinctly separate field of study. And so, ecological economics is a method of understanding and managing the economy as a subsystem of both natural and a human system. And it has a goal of preservation of natural capital, and the goods and services are related to the natural world. Environmental and ecological economists attempt to assign monetary value to intangible benefits and natural capital. This practice is known as valuation. So these folks have developed methods for assessing the monetary value of pristine natural preserves, and like the spotted owl or a scenic view. One method is calculating the revenue generated by people who pay to see these things and people who would pay to benefit from it. Like the amount of tourists who pay to visit some sort of nature reserve. That would represent a dollar value to a preserve at least. Another method is also to use surveys. They may ask a number of different people how much they're willing to pay to just know that the spotted owl exists, even if they're unlikely to ever even see one. The most extensive assessment has been attempted to determine the value of ecosystem services like oxygen that plants produce and pollution and insects take away. So estimates on this kind of stuff can vary, as you can imagine. Global ecosystem services might have a dollar value like 30 trillion per year. In 2004, the Millennium Ecosystem Assessment categorized the variety of services that ecosystems provide for human benefit. And in many cases, it's possible to estimate the cost of a particular service if it were provided using technology rather than provided naturally. We can discuss that at length, but let's just say New York City could have constructed a massive water for purification system at some sort of known cost. They could have done that, but instead they choose to protect a watershed, like their mountain region of northern New York, then that supplies the city with water. So the water would not necessarily be expensive part of purification, but you kind of get the idea. It's hard to assess a value on that. The ecosystem service of water purification has a known value, and that actually is something that we can use in our future to basically help calculate total dollar value of ecosystem services. So calculating this ecosystem service value is pretty complicated, but we've done it, at least in part, that we think. I mean, it's complicated in that you have to take into account like taxes and a lot externalities and human labor and that kind of thing. But critics to our current economic system maintain that it is basically based on maximizing the utilization of resources, energy, and human labor. And this encourages the extraction of large amounts of natural resources, and it does not provide any incentives that would reduce the amount of waste that would be generated. So we look at this figure here, we can see a system analysis of the current situation. And this suggests that continuing with such a system that we have is just really not suitable. In our current system, large amounts of extracted resources and energy are relatively small amounts of ecosystem services are inputs, and large amounts of waste are the outputs. A sustainable economic system will rely on systems and services that can be reused and coexist. So here we can see another figure that attempts to show a suitable economic system. And it relies more on an ecosystem service and reuse of existing manufacturing materials and less on the resources of extraction. And in this system, there's a greater reliance on ecosystem services and less of a reliance on resource extraction that requires all this energy. It also takes some of the wastewater system and reuses it in the production and the consumption cycle. And as indicated by those arrows labeled waste stream recycling, you can see how it's reusing the actual water. So the cycle would use more renewable energy and lessen the negative externalities and reuse more of the products that were designed to initially go into a waste system. And this model has led to architects and environmental scientists and engineers to kind of collaborate and discuss the optimal way to design and also manufacture and use and dispose of objects like automobiles, houses, and consumer goods. All right, so here's how this works. Currently, like a consumer purchases an object, like an automobile or a computer. And when that object has reached its end of its life and its useful term, the consumer is responsible for disposing of that. And as we've pointed out before, because the responsibility of that relies on the object with the consumer, there's really no incentive for the manufacturer to make it easy to reuse and recycle that object, like the laptop or whatever. So observers on this current situation have noted the irony in this. Because if you think about it, a can of chemical cleaner, like oven cleaner, you can purchase that for $5, but the chemical inside of it may cost $20 to dispose of. And these kinds of discussions have led to what we call cradle to the grave or cradle to cradle analysis, as we need to talk about. Cradle to cradle system includes human capital, resources, and energy inputs, as well as redirection of waste, the waste system and the waste stream. It gains even greater importance when we consider the entire economic system and its value altogether. So the ultimate goal here would be to produce a good that at the end of its actual useful life, it approaches its grave. Technically, it can be easily reused to make a new product. Most of all, the parts of something, old parts, can become a new part. So cradle to cradle, the beginning of life, for all of these products. An automobile would be an ideal cradle-to-cradle system and situation because each individual car contains a ton of steel and other metals, as well as like rubber and plastic, just all kinds of stuff that we can reuse.